In this lesson, you will learn how to count in Bash. Let's say I have a variable x and I will use x lowercase. X has value of 10, and I have also a variable y with value 2. How much is x minus y? Someone could start with something like echo $x minus $y. Unfortunately, this will just show 10 minus 2. Here only the variables have been replaced with the values and that was all. It doesn't work like this. But what can be made about it? We can use an extra notation that is responsible for counting. It's $, 2 opening brackets, expression that should be evaluated, and 2 closing brackets. So now the result is correct. What's interesting, in this case the dollar signs can be removed. The result remains correct. What is much better, we even don't need the additional spaces that normally in Bash are mandatory. But normally when calculating something, we usually want to save the results somewhere. Luckily, that's easy. It's enough to add variable name equals and ready. When we check the variable's value, it is 8. When using this syntax for calculations, we can do simultaneously more actions at one shot. Look at this example. First, x will be divided by 2, so now x value will be 5. Second, y will be doubled, so now it's equal 4. Next, z will be assigned value 5 minus 4, so it will be 1. And finally, u will have value 5 times 4, so 20. So we have here 4 expressions separated by comma. 2 new variables have been created and the returned value is the value of the last expression from the list. If you don't believe, we can check the values of the variables after all. 5, 4, 1, 20. The discussed here notation allows also for calculations in the style of language C++. In C++, when you want to increment a value of a variable, you can type x plus plus. Currently x is equal 5. After this operation, x will be increased by 1, so it will be equal 6. Why was then 5 displayed? That's because I said after this operation x will be increased. That means that first we have displayed the value of x and the value was still 5, and later we increased the value to 6. So when I execute the command once again, I will see 6, but x should have value of 7. Once again I see 7, but the value of x is now 8. So when I test the x value by displaying it, I can see that the value is indeed 8. Let's remind that the y has value of 4. So is the x bigger than y? The value 1 was returned and it reflects a logical value of true. And is it true that x is lower than y? The result is 0, so false. And is it true that x is equal y? No, true. And is it true that x is equal x? So this type of notation allows us to do some mathematical calculations but also perform simple logical expressions. Some trouble may be observed especially when dividing the numbers, because all the calculations are done here on integers. 20 divided by 5 is 4, 20 divided by 10 is 2, but 20 divided by 15 is only 1. 20 divided by 11 is still only 1, but if a mathematical round operation would be used, it should be rather 2. So the calculations here are pure integer operations. For a scientist that could be a problem, but for a sysadmin, I suppose that's not a huge issue. So try to remember $ and double opening and closing brackets with the variables and arithmetical operations inside. That's the recommended way of performing calculations in Bash. However, if you would need to read the existing older scripts developed some time ago by someone else, you may still see other ways of calculating mathematical expressions. That's why we will now learn command exp. With exp, you can again pass as arguments variables or a string containing text that could be interpreted as a numeric value with a limited set of arithmetical operators. Now we used x and y, and the result of adding those two values is 12. If you wish to work on a constant value, no problem. Just type the new constant value, x plus 1 equals 9. Let's check if it's still possible to delete the dollar sign in front of x. No. Is it possible to remove the additional spaces around the plus sign? No. That means that exp requires a very strict syntax. Let's continue with our experiments. Can we subtract? No problem. 8 minus 4 equals 4. Great. Can we divide? X divided by y. 2. That's good. So surely we can multiply as well. X multiplied by y and error. And that's quite stupid error, because there is a problem with commands.txt. But we didn't put anything like that in the command. What's going on? Well, if we list the current directory, then indeed there is a command.txt file here. But what has it in common with the multiply operation? Multiply symbol is asterisk, and asterisk is a meta character matching all files and subdirectories. So the command that exp was supposed to execute was 8, the value of x, next the names of all files from the current directory, and finally 4, the value of y. Operation like that needed to fail. To correct this situation, we should precede the asterisk with a backslash, which will quote the asterisk. So exp will see indeed asterisk as a symbol pointing to multiply operation. So that is how we can use the 4 basic arithmetical operations with exp. Now see how the result of that operation can be saved in a variable. If you wish to save the result of the exp calculation in a z variable, type z equals $, and in the brackets put the expression that should be evaluated. It works, but the syntax is not so nice as in the previous examples. Due to long Linux and Bash history, let me present one more way of getting results of a command. Instead of $ and brackets, sometimes a reverse apostrophe is used. On most keyboards, the reverse apostrophe is on the same button as the tilde, and tilde is usually under escape. That is working correctly, but the reverse apostrophe is small, someone could read it as an apostrophe, and the other would think that it's just a mist on the screen. So we have seen 2 methods of doing math in Bash. Are there more? Yes, there is, for example, a dedicated program named BC. Less or more, it's a kind of scientific calculator. You enter some quite intuitive expressions, and BC should display the result. A is 200, B is 100. C should be A minus 3 times B. So what value has C? It's minus 100. Of course, we are here more interested in using a calculator in batch mode. We don't want interactively enter expressions and check the results. So for us, it would be better somehow to pass arguments to BC so that BC will be able to perform some calculations and will return a result that could be stored in another variable. How to do it? For this, we need to send to BC via a pipe a text. The text should contain the expression that BC is going to interpret as mathematical expression. In our case, echo outputs text 8 plus 4. BC gets this text on standard input and returns the result, 12. If you would like to save the result in a variable again, you already know what should be done. Use the $ and bracket syntax. The same trick as just for a moment with the exp. It works, but wouldn't the $ with double brackets be easier? Surely, but at least we know now 3 methods for calculating value of mathematical expressions. Would you be interested more on this topic? Yes, there are more methods. We have let, we have declare, but I think that it would be enough for now. Someone could wonder why we have so many methods for doing the same thing in shell. Wouldn't just one good method be better instead of multiple ways of adding values? I think that the reason of that status is again history. Bash, and more generally shell, were supposed to be used by system administrators. Disk operations, managing processes, devices should be the essential activities done by admin. The calculations are more business application specific, so at the very beginning the calculation in Bash was not so important. With time, different authors developed solutions for performing basic calculations. One used exp, the other BC. Finally, the dollar and double bracket method was made available. Now we are at this point in the history where you can select the method that you like the most. The choice is yours. This lesson was dedicated to calculations in Bash. In the next lesson we will work with strings. See you soon.